Hello everyone, this is Professor Lee. Today we are going to study chapter 2 and 2.3 more specifically, and it's about measures of location of data, right? I always think the title of each chapter is very important because it tells you exactly what that chapter is about in a couple of words, right? So, in this chapter, we are going to check what would be the measures of location of the data, right? Location of the data. All right, so let's get into this. First, two concepts that we would like to study is about percentile and quartile. Now, quartiles and percentiles are two different concepts that two similar but different concepts that one divide, for example, quartile divide order data into quarters, 4 parts, right? And percentile divide order data into 100 pieces, right? That's percentile. I mean, when we say percent, that means out of 100, right? So percentile, 100, quarter, quartile, into 4 parts, right? Quarters. Okay, so let's say to score 90th percentile on an exam, what does that mean? That does not necessarily means that you get the 90% of the correct answer, right? It's not what it means to be in 90th percentile. That means from the lowest score to, let's say this is the highest score, you cut that into 100 pieces, and then your 90th percentiles are right here. That means below you, 90%. Above you, out of 100, up to here, I guess it's going to be 10%. That's what 90th percentile really means. So it really means that 90% of the test scores are the same or less than you, and only 10% test score are the same or greater than you. So, if your score is in 90th percentile, that means most likely you are in top 10%. You are at the top 10% level, right? Below you, 90%, right? So, let's say you are at the, 10%. You are at the 10 percentile. That means what? You are not doing well, right? 10 percentile is right here. Below you, 10%. Above you, it's going to be 90%. That's what percentile really means. So K's percentile really means anywhere from 1% to 99%, right? So that K% are going to be less than or equal to your position, right? Less than equal to of your position, right? That's a percentile. Now, quartile, however, cut that into how many pieces? 4 equal parts. So, let's say this is the smallest point, smallest data value. Let's say this is the largest or highest data value. You cut that right in the middle. That's going to be called q2, or you can also call that median. Median really means the middle value. right? Middle value of this whole data array. So I guess to figure out the quartile, you really have to put them in order first, right? From the smallest to the largest first. Once you arrange from smallest to the largest, then you figure out the middle point. That middle point is going to call median or Q2. All right, once you identified it Q2, now you have the first half, and you have the second half. Now, from the first half, you cut in the middle again. That point right there is going to be Q1 point. So from the smallest to Q1, you can see that there's a 25% of the data falls into this interval, right? Falls into this interval. And also from Q1 to Q2, another 25% falls into this interval. And you get the idea of how we find the Q3, right? From the second half, you take the half, you find another middle point. And that point is going to be Q3 point. So each interval has same 25% each. So that type of dividing scheme is called quartile, puts it into quartile, right? Okay, so percentile cuts it into 100 pieces just like that, right? And quartile puts it into 4 pieces just like that. All right, so again, quartile, 4 quarters, right? And percentile, 100 pieces, right? Just to recap. Okay. Now, there's another term that we need to know, which is called IQR. Stands for interquartile range. Interquartile range. So, how do you find IQR? Well, you find IQR by doing this simple subtraction. Q3 point minus Q1 point. So, later on we are going to do the actual example. Then you will find this Q1, Q2, Q3. Once you find this point, then just Q3 minus Q1 will give you IQR. So what is this IQR? That refers to the range of middle 50%, because if you really think about it, this is the smallest, this is the largest. You find the middle value, it's going to be Q2. You find the middle of the first half, it's going to be Q1. You find the middle of the second half, it's going to be Q3. So difference from here to here, Q3 to Q1, that's going to be middle 50% right there. That's another 25% there, another 25% here. So it's really going to be middle 50% right there, right? That's going to be IQR value. Okay. Box plot. So this is next chapter 2.4. In this lecture video, we are going to combine Q3 2.3 and 2.4 together, right? Because it's relatively short chapter. So 2.5 to 4 is really about box plot. So box plot, in order to build the box plot, we need what's called the 5-number summary. Now, 5-number summary is, kind of easy, because remember that you have the data array from smallest value in here, we call that minimum value, and we have the maximum value. We find the middle value, it's going to be Q2, but it's also known as M or the median, right? This M really stands for the median. You find the Q1 here, you find the Q3 there. So what's 5-number summary? Well, this minimum value Q1, M, which is really Q2, Q3, and the maximum value. These 5-number, right here, it's called 5-number summary. 5-number summary. Now, even at this point, a lot of you are still a little bit, unsure because we didn't actually do the actual example yet. So, let's do the actual example. So, in order to make or draw box plot, we need this 5-number, right? And this box plot, sometimes it's just called box plot, sometimes it's called box and whisker plot. Same thing. And let's see how we actually make this box plot. Let me actually show you the box plot first. Box plot looks like this, right? This type of box shape in the middle. And then we have these 2 lines. Remember that it's also called box and whisker plot. And there's this whisker, right? So how do we actually build this box plot? Well, let's try this example. And we are going to try this by using our calculator, right? So we are going to use TI-84 as our main calculator, and I'll show you how to do this with the TI-84 calculator, right? So let's say you have a bunch of data points right here. This is the raw data. Now, let's say this is an exam result or something. And how many data points that we have? Oh, this is a height, right? Sorry, this is a height of 40 students. So this is a height of 40 students. And luckily, this data is already in order, right? This is already in order. But it's okay to have a data which is not in order, right? So from this data, we are figuring out the minimum point right there, figuring out the maximum point right there. It's not that difficult, right? It's just right there. But why did I circle this? This is not it. This is the maximum point, right? 70 maximum point. So finding the minimum point, the maximum point is not that difficult just by looking at this data point. But where's so I guess if I draw the line, I guess this one is 59, this is 77. Where is this middle point then? Well, according to this calculation, the middle point is 66. And if you take another middle of these array, then it's going to be 64.5. And another middle of the second half is going to be 70, like that. So these 5-number makes up the 5-number summary. Now from this 5-number summary, we are going to eventually draw something like this box plot. We're going to get to this part just a short while. But first, how do we find these 5-number by using our calculator? Well, the explanation is right here. Let me switch the sharing option. Let me actually exit the full screen view, and let me share this one right here. My computer screen, these two, right? Okay, so now you see my computer screen, right? I have my calculator right here, and this part is the explanation part right there. So First thing that we should do, we should turn on the calculator, right? We should turn on the calculator. So putting it on, I'm just going to clear the screen. First thing that we should do, press this stats button once, this button right here, and choose the edit. So which is first option already there. So I'm just going to put enter. Now, sometimes you might have all the data point already stored right there or something. You know, let me just store a couple of data. Then what you can do, you can just hit clear. Oh, move that to this part right there, and then hit clear once and enter. And it'll clear all the data point right there. Make sure that you don't hit the clear button 2 times. If you hit the clear button 2 times, it'll actually delete the first columns, right? Then you have to reset the whole calculator, right? So, I mean, there are 40 data points, which is a bit tedious, but I'm going to do it anyway, just to show you just once. So, in that L1 column, right, we put stats and hit enter to get here. Put all these 40 numbers. So 59, enter. You see this 59 entered there. Then 60, then 61, and 62. So another 60, I'm going through this number, another 62, 63, another 63, 64, another 64, another 64, 65, 65, another 65, oops, so another, oh, let me go back, delete, 65. So far I have 1, 2, 3, 6, 5. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 5. So I'm gonna do 6, 5, 6, 5, 6, 5. 6, 5, 6, 5. I think I have 9. Okay. Now I have 6, 6, and another 6, 6. So 6, 6, another 6, 6. Hopefully I'm not making any mistake. 6, 7, 6, 7, 6, 8, another 6, 8, and 6, 9, and 1, 2, 3, 4, 5, 7, 0. So 7, 0, 7, 0, 0, 7, 0, and 7, 0, and then 71, 71, and 72, 72, 7, nope, not 3, 7, 7, 3, 7, 3, 7, 4, 7, 4, 7, 5, 7, 7. You know what? I'm supposed to have 40 data points. That means I missed something. So let's go back and check which one that I missed. So 59, 60, 61, 62, 1 and 2, 7, 63, 1, 2, and 64, another 64, another 64, 65, 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, so we are missing 165. So I guess I'm just gonna add 65 right there. Okay, so it's slightly different order, but I'm sure this is all correct. Now, then what? Press Stat button again and move the arrow key to calculate. So we're going to move that to here. So calculate. And one variable, choose one variable right there. Then what? One variable right there. Then hit enter, right? One variable, hit enter. And list is going to be L1. We put all those things in L1. So hit enter. Frequency, you don't have to worry about that. And calculate. Okay, here we go. It gives you, well, we'll talk about this later, right? So look at this. If I just scroll down, it has the minimum number, 59, Q1, 64.5, the M or the Q2, 66, the Q3, which is 70, the maximum number, 77. So that 5-number summary that we just saw is going to be right here, right? It's going to be right here, right? So using this TI-84 calculator, it's very easy in a way to figure out all those Q1, Q2, Q3, and maximum number and minimum number. So we got all these 5 number right from the calculator, right? And I would definitely recommend you to try this on your own and make sure you get the same answer. Now, I rewrote that right here. The minimum, Q1, Q2, Q3, and the maximum. And let me show you how we build this. Now, first thing that I'll do, I'll check the minimum number and the maximum number and make a line, number line. And I'll say, oh, minimum number is 59, so it's better to have like number that's smaller than this, and that's about, maximum number is 77, so it should be bigger than, so I'll go anywhere between 55 to 80. So let's say this is about 60, and this is about 65, and this is about 70, and this is about 75, and this is about 80. So once I get my number line like that, these 3 numbers in the middle will make a box. So Q1 is at 64.5. It's 64.5 should be a little less than this, so it should be about here. That's this number. And Q2, 66 should be, this is 65, so should be about here. That's this number. And 70 is right here in my graph, right here. That's a 70 right there. And I'm going to make a box with these 3 numbers, right? So this is a Q1, this is Q2, and this is Q3. Now from Q1, I'm going to go all the way down to my minimum number. Minimum number right here. So let's say this is my minimum number, which is going to be 59. And I'm just connecting the line. And that's a whisker part. And the maximum is at 77, so this is 75, so 77 should be about here. I'll say that's a 77. Make another line like that. And that's my box and whisker plot, or just say box plot. I mean, you have a prettier graph or plot, whatever, that's right there. Right? And that's how you make this box plot. Okay. Now, how do you check for outlier? Well, first of all, what is outlier? Outlier is an extremely big or extremely small value, right, than other values. For example, let's say you became a CEO of this huge company, and you have to give a payroll to, let's say, 5,000 employee of yours. Now, it's difficult to check one by one manually, so you put all those numbers in the Excel or something, and you manage your payroll. Well, in reality, you hire the payroll company to do that. But let's just hypothetically say that you have to, put the number 5,000 number in Excel program. Now, let's say, of course, that you are not doing it. You let your secretary do that, and you have to pay this person, let's say, $75,000 per year. This next person is $58,000 per year. This next person, you're supposed to pay, say, $79,000. But by accident, your secretary forgot to put the decimal point here and just add these two number, by mistake. Now, this person who's supposed to get paid, $79,000 per year, but all of a sudden, this person is getting about 8 million per year, right? So he or she got the first paycheck, and it's bigger than what he or she sold, and that person is not saying anything. I'm not complaining. I mean, they pay me more, fine. I'll take that. So what if this person is not saying anything and just keep his or her mouth shut and getting nice payment, right? So you must have a way to detect this extremely large number or extremely small number. For example, the next person is supposed to get paid $70,000, but instead of putting comma by accident, put a dot there. So this person is actually getting $70 per year, right? Which is not, I'm sure that person is not going to be quiet. But the point is, extremely big number or extremely small number is called the outlier. So how small or how big that number should be in order to be classified as outlier? Well, these 4 steps is going to tell you how to figure out the outlier. First thing, you have to find Q1 and Q3. Now, what's Q1 and Q3? Well, that's in this 5 number somewhere, Q1 and Q3. Right? So once you find the Q1 and Q3, then you find this interquartile range, IQR, Q3 minus Q1, right? So you find that. All right. So once you find the Q1, Q3, and interquartile range, now it's time to build the fence. You build the lower fence, and you build the upper fence. So how do you build this? Lower fence is going to be Q1 minus 1.5 times IQR. At the end, this Q1 and IQR, these are all going to be a number. right? So you build a fence like that. And you build the upper fence also by putting Q3 plus, remember this time it's going to be plus 1.5 and IQR, right? So this will give you a two different number, which will give you the lower fence and upper fence. Now, any number which is not between this lower fence and upper fence is going to be considered as an outlier. Considered as an outlier. Well, let's check out this example. Same example, right? So we have this 5 number. So step 1, we find the Q1 and Q3, right? We have the Q1 and Q3. Find IQR, Q3 minus Q1, 5.5. Lower fence, 64.5 minus 1.5 times 5.5, and you get this number. Upper fence, likewise. Now, when you type it up in the calculator, you can type it up exactly same, or you can do this, minus 1.5 times 5.5 and return. Instead of the parentheses, we can type it up like that too. And it'll give you the same answer. And this one, we just change that to plus. And it will give you this. So, any number not between these two numbers, if we have any number not between these two, that's going to be considered as outlier. But remember, our minimum is 59, bigger than this number. Our maximum was 77, which is smaller than this number. So we know in this data set, there is no outlier because every single number in here is going to fall between these two numbers. That means there's no outlier. But, of course, sometimes then you will have number not in between those two, and that number is going to be considered as outlier. Okay, and that's read for today. Right?